Hello, everyone. Welcome to 8.06. Just a quick reminder, if you picked up the packet at school last week, there was a few typos within the packet. So this attached file, the PDF file in your assignment section, is the most up-to-date version. And that's what I'm using here to do the notes. So what we're going to do is the first two pages here, 806, more double triangles. We're going to do this page. And your homework is actually going to be the classwork assignment that's attached. So I'm going to kind of give you some hints along the way as we go through these notes. So please join me at the top here. Again, it's notes on some double triangle questions. So here we have a tower that's located 327 feet from a building. A person from the second story in the tower, so they're here on the second floor, measures an angle of elevation to the top of the tower of 32 degrees and an angle of depression to the base of the tower of 18 degrees. Find the height of the tower to the nearest tenth of a foot. And these calculations happen all the time. So the final answer we're looking here is the entire height of the tower. But how we're going to do this question is I'm going to break it up into two right triangles. So if I go over and up, I have one right triangle with that angle of 32 degrees, and I know how far the building is from the tower is 327. I'm going to redraw that right triangle. Your angle is going to be 32, 327 feet out, and I'm going to find that measure to be x, is that height there. Then I'm going to look at the bottom right triangle. So from the person standing on the second story, looking down, we have a second right triangle, which is going to be an angle of depression is 18 degrees. Again, the measure from the person to the tower is 327 feet. And we're going to find the height from here to be y. And then the entire tower's length will be the sum of this measure plus y. So we're going to end by adding x to y. So from our angle of 32, we have an opposite side and an adjacent side. So opposite adjacent is our tangent function. So tangent 32 equals opposite x over adjacent 327. Okay. And this assignment is actually really good mixed review toward the quiz that we're going to have next week on Monday. So you'll get more information about that in classroom today as well. So solving for this triangle, remember if x is in that numerator, we're going to just cross multiply. So we have 327 times tan 32, and we get x to be approximately 204 point 332. Okay. The next picture, we're going to find y. So here we have from our 18 degrees, the opposite side is y, adjacent is 327. So again, we're using our tangent function of 18 degrees. Remember to put the angle equals y over 327. So again, 327 times tan 18 gives us 106.2487. And we're going to find the sum of those two measures. So in my calculator, I'm going to go up, I'm going to grab this answer and add it to the 106. And our final answer for the height of the tower is going to be y gives us 310.581. Now double checking our rounding, it asks for the nearest tenth of a foot. So our last and final answer is going to be 310 point, and that 8 will round our 5 to a 6. So our final answer is going to be 310.6 feet. Now question number 2, we've actually already done on a different notes page. So if you'd like extra credit, or I'm sorry, extra practice, I should say, you can try number 2. It's kind of the same idea, splitting into 2 right triangles. But I'm going to switch ahead to number 3 here. And this was similar to a homework question on 804B, the back of 804B. So the boat is trying to determine its speed. So that's a new little piece that we're going to see in feet per minute. The boat spots a 245-foot tall lighthouse at point A, and its angle of elevation was 12 degrees. And 5 minutes later is going to be the key piece to finding our speed in a minute here. Whereas at point B, after traveling in a straight line toward the lighthouse, and its angle of elevation is now 28 degrees. So we have those 2 measures. What is the boat's speed? So that formula that we're going to need at the very end of this question is, remember that distance equals rate times time. The DIRT formula, DRT. Distance equals rate times time. So what we're going to be finding is the speed is the R value in that formula there. So looking at the diagram, what we're going to need is the distance before we can use this distance equals rate times time piece. So the measures we know as of now are 2 angles, 12 degrees and 28, and a height. What we're looking for is how far it went from point A to point B. So that's going to be our X measurement. But as we've done before, we have 2 right triangles here. We have the big right triangle. I'm going to do that in a brighter color for you. We have the big right triangle, which has 245 as the height of the light tower, a 12-degree angle, and we're going to find from A to the lighthouse to be side A. So from A over to your lighthouse is side A. And then the second right triangle is in here, the lighthouse to the boat at B. So again, we have 2 right triangles. So we have the 28-degree angle, 245 is the height, and we're gonna find the measure from the boat B to the lighthouse is B, where the final measure to find X here is the whole distance, subtract B will leave us with X. So at the very end here, we're gonna have X equals subtract B. So to find side A, let's go to that first right triangle. From 12, we have the opposite side and we have the adjacent side. So remember, T goes over A. So tan from 12 degrees equals 245 over A. I'm going to solve that in a second. I'm going to set up the other one because it's very similar. Again, the opposite side is the 245. The adjacent is B. So tangent from our 28-degree angle will equal 245 over B. Now to solve these, a little hint and a reminder is that that variable is in your denominator. You're going to end up dividing over here in your calculator. So A will equal 245 divided by tan 12. Now on the last question, our variable on number 1 there was in the numerator. So I had just cross multiplied these 2 cases, the denominator to up here. That's just something I keep seeing a mistake of. Sometimes you guys aren't sure if you're dividing or multiplying. So since A is in the denominator, when you do your cross products, you end up dividing by tan 12. If I take 245 divided by tangent of 12, we get A measure. We'll get A to be 1152.633. So I'm going to leave that for a second. And then when we're solving for B, we're also going to take 245 and divide by tan 28. So 245 divided by tan 28 is the other angle measure. We get B is 460.7779. So again, I like those measures to 4 decimal places because those are just parts of our answer. To find our final answer, again, we know that the first ship to the tower was about 1,152 meters or feet out. I guess we're measuring here. From point B, we now are only 460 away. So the difference in those two answers, so if I take the measure of A, the 1152, and subtract the measure B, we find that the boat had traveled, so A subtract B here is going to be 691.8563. So that's how far it traveled, but that's not what the question asked us. So let's go back up here. What they asked us was, what's the boat's speed to the nearest foot per minute? So if it traveled 690 feet from here to here and it took 5 minutes of time to get there, we're going to take our feet and divide by 5 minutes to find out how many feet per minute it traveled. So taking our answer and simply dividing by 5, we're going to get the boat went 138 feet per. So again, that answer came from dividing by 5 minutes because we had feet as a measurement. And if it goes that many feet in 5 minutes, it's going to go 138 feet per 1 minute. So we just divided by 5. Next example, 4, is actually a case that kind of is missing some of its directions. We're going to find A, the length of a roof rafter, and B, the measure of the angle. And we're going to round here for number 4 to the 10th place. So that's something that was missing from your directions. But if you think about the roof of your house, okay, it kind of comes up to a point, and both edges of a roof are typically equal. So that's what you have your marking here and here to be. The measurement off to the side tells you that the height of the roof from the top to the bottom is 8 feet. So that measurement can actually jump into the middle of our picture. So that 8 feet, I'm going to transfer over into here. Because what that's going to do to this big isosceles triangle is now it breaks it into 2 right triangles. So we have 8 feet up from top to bottom of the roof, and the whole length of the house is 32 feet across. Well, when we draw in this perpendicular altitude, that's going to split your 32 into 2 pieces. So we're going to have 16 as one measure here. And that's where your right triangle kind of gets formed. So looking at the picture, so again, we have the roof rafter. So again, if you think about your house, and here's your roof, the rafters are these 2 diagonal pieces. So it's 8 feet from top to bottom, and the whole width of the house would be 32. So if you're struggling to kind of see that, those are the measures we have. So here it asks to find the length of the roof rafter, which is from the top piece diagonally down to point A. Now I'm going to resketch that little orange triangle for a second. The measures we have right now is 8 up, 16 across, and find the third side, we're going to use our Pythagorean theorem. So if we take 8 squared plus, now 16 is the other leg, so that goes here, equals c squared, because we're finding the hypotenuse. And I'll tell you, 8 squared gives you 4, 16 squared is 256, equals c squared. Bump that up. C squared will equal, that sum is 320. And we take the square root of each side. So we have the square root of 320 gives us that roof factor is going to be approximately 17.88. Rounded again, I asked us to the 10th place, is going to be 17.9. So that's your answer to part A here, 17.9. Part B is asking for the measure of angle A. So again, resketching the triangle we had is here. We have 16 over and 8 up to find the measure of an angle. So again, when we have 3 sides of a right triangle, we can use our Pythagorean theorem. And when we're trying to find an angle of our shape, we use SOHCAHTOA. So to find an angle, we have to decide, is it sine, cosine, or tangent? Now I'm not going to use the answer that we just got. I'm going to stick with the 16 and 8 for a second. So the 16 is adjacent to angle A, and 8 is opposite, so it's going to be a tangent function. And I'm going to put x variable in at angle A, and x equals the opposite 8 over 16. Now remember, to find an angle, we need to put in the inverse function, which is going to be tan to the negative 1. So x equals tan to the negative 1 of 8 over 16. And on your calculator, what we have so far, second tan, 8 divided by 16 is going to give us 26. X equals 26.56 degrees. So rounded to the 10th place is going to be 26.6 degrees. How big that angle A is there. So that's it really for the new notes. But that was a really good review of where your variable can fall within our trig function. So looking here, we had a variable as the angle, and we needed inverse trig functions. Looking back at number 3, we had our variable in the denominator of our trig function. So we had to divide when we solved for it. And same with number 1, we had the variable we were looking for, the part we were looking for of our picture in our numerator. So those are 3 things we're going to look to be kind of quizzing and making sure you are successful in at the beginning of next week. Because again, these topics are necessary for the next course you're going to be taking in your teachers. What we'd like you to do for homework, for next time, is this classwork 806. So there's 4 questions here. I'm going to give you a few hints. Number 1, the hint I'm going to tell you is this is very similar to example 3 from the classwork we just did, or the notes we just did. You're going to have 2 right triangles. You have the smaller right triangle, and you're going to look to find the height of the factory. So if I redraw that one. So you're going to find the height of the factory, A. You're given some other measures, so I want you to take an opportunity to actually label it out yourself. And then the second right triangle is the tall one, from the factory all the way up to the top of the smokestack. It's going to be the other right triangle. So you're going to look to find the measures for both of these pictures. And I'm going to tell you the whole measure from top to bottom is going to be B. So I'm going to put that on a green triangle for you. Right? Now what they're looking for is the height of the smokestack. So if you find the height here, A, for just the top to bottom of the factory, and you find the whole thing B. Now B is larger, A is smaller. The height of the smokestack will be really what we're looking for, X. So X in this case will be what I've marked as B, the whole measure, subtract A. Will leave you with just the height of the smokestack. So that's a little hint there. Please label up the diagram based on what it says there for number 1. Number 2, again, 2 right triangles listed here. You have the whole lighthouse over to the closer boat. Now, these 2 angles of elevation, when you're closer, your angle is going to be larger. So that first angle to the first boat from the lighthouse, so say this is boat 1 and this is boat 2, that's going to be 12 degrees. The second right triangle is from your lighthouse all the way over to boat 2. That is stretched farther out, so the angle becomes smaller. It's 10 degrees. And they're asking for how far apart are the 2 boats. So again, that's the same idea where you're looking for the distance between the 2 boats. So if I put an X there, you're looking for the distance between your boats. Moving to the next page. Here, just so you know, it's a little bit mismarked. We have exercise 3, and then we also have exercise 5 that we want you to be doing here as the homework questions. The trick here with number 3 is the units. So I'm just going to read this one. It says, as modeled in the diagram below, the access ramp starts on flat ground and ends at the beginning of the top step. So here, if you imagine a building, there's a ramp up into the building, and here are the steps into the building kind of next to the ramp. Each step is 6 inches tall and 8 inches deep. So that's marked here for you. Part A, let's say, says if the angle of elevation of the ramp is 4.76 degrees. So the angle here is 4.76 degrees. Determine and state the length of the ramp to the nearest tenth of a foot. So I'm going to put an X there for the length of the ramp. So from the beginning of the ramp all the way up to the top step is what they're looking for. So if we draw in that right triangle, it goes straight down and over. So right now we have this 4.76 degrees, so we have an angle. The length of the ramp, X. Find the length of the ramp, the nearest foot. So now when I'm looking at these measurements, it says 6 inches, 6 inches, 6 inches. So if I need to find something in feet, we need to remember 12 inches, 1 foot. So a measure we do know is how far it is from the floor all the way up to the top step. So we have 6 inches from here to here, another 6 inches, another 6 inches. It's going to be 6 inches times 3 steps is going to be 12 inches. I'm sorry. Try that again. Miss Block. Is 18 tall. But again, if we want to be finding this in feet, we don't want 18 inches. We want to convert that into feet. So 18 inches divided by 12, there's 12 inches per foot, so we do division. 18 divided by 12 gives us a smaller unit, which will be 1.5. So you're going to find the length of the ramp, X, in feet, using your 4.6 degrees, your 1.5 feet tall is how high that right triangle is. Now for part B, it asks you to find and state to the nearest tenth of a foot the horizontal distance D from the bottom of the stairs to the bottom of the ramp. So D only goes from here over to here. So we could try to make a right triangle there, but you're going to be missing some of your height up in this section. So my suggestion is to know that from the bottom step to this height here that we have, it's going to be 16 inches, 8 and 8, because there's 2 steps in. So my suggestion is to subtract those inches out after you find the horizontal distance D. So the second picture that we're going to have is going to be the 4.76. We're going to have 1.5 feet up. We still know those two measurements. But now we're looking for the distance D here. So that's going to change what trig function you're going to use. So again, you're going to set up a trig function here. You have an opposite side, you have a hypotenuse, and you're going to go from there. But this second question, what we have is the opposite side and this distance here. So I'm going to say to find the whole measure across, say x, and x subtract 16 inches is going to give you your horizontal distance D. So now remember, you're going to have to convert those inches to feet as well here. So you might want to just keep it as a fraction, but go ahead and try part B. Lastly, number 5, which would really be the fourth example, just kind of misnumbered. There's going to be another two right triangles here. So you have triangle ABX, and the other bigger right triangle ABY. Now what they're going to be looking for is the measure of the angle XAY. So from X up to A down to Y. So that's kind of the difference between two angles here. So my suggestion is to find your angles X and Y first within these two diagrams, and there's some measurements given to you. I want you to read that and label your pictures accordingly. And then use your big picture here to find the missing angle up here that they're speaking of. So they're trying to look for that little sliver of an angle up top there. Good luck with everything. Email or send us a private message if you need some help or want to set up a Google Meet session to discuss any questions. Thank you. Have a great day.